everyone, and welcome to another All-Deck video. My name is Chantel, and this video is going to be about interfacing TortoiseGit with Active-HDL. Active-HDL is known as a powerful IDE for team-based environments, and when it comes to teamwork, it's essential to keep collaboration with each other efficient while keeping track of a project's development. And that's where TortoiseGit comes in. This is an easy-to-use and freely available Windows shell interface to Git based on Tortoise SVN. TortoiseGit easily integrates with Active-HDL, allowing for full control of a project's design, synthesis, and implementation files for the entire team. And now I'll go ahead and demonstrate that for you guys. Since this is an interface to Git, the first thing to do, if not already done, is to install Git to your Windows computer. The next thing to do is to install the latest version of TortoiseGit. Make sure that the version of Git that's installed and the version of Windows used are compatible. Just download the setup package from the website, which I've linked in the description below. Once Git and TortoiseGit have been installed, there is a zip file that needs to be downloaded. This contains All-Deck's pre-made TortoiseGit batch and tickle scripts that will be used in Active-HDL. If you'd like this zip file, please contact us through our website. For this zip file, you'll need to extract all the contents into the bin directory of Active-HDL. As you can see, there are 7 different files, 4 of which are batch and the other 3 tickle scripts. And now, let's go ahead and add these files to integrate TortoiseGit with Active-HDL. Inside of Active-HDL, go to Tools, Preferences, and then File Tools will be under Tools in the Environment section. These will be the TortoiseGit tools that will be accessible through the context menu of design files. The file tools I'll be adding will be the batch files from the folder that was downloaded. So for each one, you'll give it a name, and below the list of tool names, source the batch file for the command, set your arguments, which I'll leave alone, and set the initial folder, which I'll also leave alone by default. Doing this for all the batch files downloaded will leave me with TortoiseGit tools for commit, diff, add, and revision graph. Once all that is done, click on Apply, and now we'll move on to the user tools. The settings for user tools is right above File Tools. These tools will be located in the Tools menu once they're implemented. These will be the tickle files from the downloaded folder. Similar to what we've already done for the file tools, just add the tools and give it a name. Then source the tickle file as the command. Set arguments, which I'll be leaving blank, and then set the initial folder. For the initial folder, I'll be sourcing the current working design using $DSN. And this will be for all 3 TickleScript tools. Once finished, I'll have 3 new tools for Git Add Design, Git Commit Design, and TortoiseGit Repo Browser. Now that all the tools have been added, I'm going to show what each of them do. First, I'm going to create a new workspace, and I'm going to give it the name Tortoise. Then I'll leave the checkbox for Add New Design to Workspace checked, and click OK. From here, the new design wizard opens, and I'm just going to use the option of Create an Empty Design. I'll change the default language to Verilog, and I'll name this design Example, and leave the Do Not Create Design directory unchecked. This option doesn't impact how TortoiseGit interacts with your design, but just be careful when selecting that option if you decide to have multiple designs within one workspace. I'll go and click Next, and then click Finish to get my new empty design. I now want to initialize this design as a Git repository. So the first integrated tool I'll be using is the user tool, git add design. For this tool, the local Git repository is initialized, then the initial existing design files are added, project sources are also added, and lastly, the initial commit is done. Just as a heads up, when first opening the commands, a security warning window may pop up asking to make sure you want to run the file. Just select yes, and make sure to also uncheck the Always Ask Before Opening This File box so that you won't have to confirm every time. Before I use this tool, in the console window, I'm going to move back one directory because the default working directory when you open a design up in Active-HDL is the design's source folder. If I had used the tool before doing this, I would have gotten some errors. So now I'm going to go to Tools and Git Add Design, as well as the other two user tools I added are located here. I'll click on it, and you can see in the console that my initialization of the design is successful. But now, let's go ahead and add a file. I'll add a new Verilog file, call it counter, click OK, and I'm going to use Language Assistant, go to Synthesis Templates, expand counters, and I'll use the synchronous up counter template. I'll save it, and for this, I'll be using a file tool called TortoiseGit add. This tool starts up the TortoiseGit process with the add command using the design repository as the path. To use file tools, just right-click on the design file, go to Open In, and the tool will be right here. When I click on TortoiseGit add, a little TortoiseGit window pops up showing that it was successfully added to my repository. I'll go and click on OK. With my counter code now added to the design repository, I'm going to right-click on the file again, and this time click on TortoiseGit commit. This tool is similar to the TortoiseGit add tool, with the only difference being that the command is now commit. A new window pops up where I can perform my commit. I'll need to type in a message, so I'll just say added new file. Leave everything as is, and now click on commit. You'll see now that my commit was successful, and I can now close. So I've committed my new file, and now I'm going to add a header to it. I'll just type _header and select the option to autocomplete a header template. This is just so that I can show the next file tool called TortoiseGit diff. Again, basically the same format as the other two files, with the command changing to diff. So now when I select this tool, this window pops up, showing the differences between what I have going on in the current working tree versus what was added and committed to my repository earlier. You can see the header being the difference between the two. I'll go and close this window, and I'm going to add another Verilog file. I'll call this dflipflop. Again, I'm going to use the Language Assistant, go to Synthesis Templates, expand the flip-flops section, and I'll use the dflipflop template. I'll save and add this to my design repository using git tortoise add again. With this, I have a few changes to my repository, so I'm going to go to the Tools menu and click on Git Commit Design to commit all the changes I've made. In the console, you'll see two lines of messages with an update with the date as the comment and the changes that occurred with this commit. And now if we want to see if everything we've committed is in the repository, you can go to the Tools menu and select TortoiseGit Repo Browser. In this script, TortoiseGit launches with the command repo browser to open up a browser window of the repository, as you can see here. I can confirm that the updated counter file and the newly added dflip-flop file are in the repository. And now let's pretend that I'm another team member working on this design, and I want to change the counter to a gray code counter. I'm going back to the language assistant and using the gray code counter template. I'll also edit the revision history to say that I've changed the counter to gray code. I want to commit these changes to a different branch because I don't want to tamper with the original work. So I'm going to use TortoiseGit commit, and this time commit to a new branch called my branch. And I'll add a comment saying new branch, changed counter code, and click commit. Now if I want to take a look at all the different branches and revision history, you can right-click on the design file, go to Open In, and click on TortoiseGit Revision Graph. This opens up a new window showing the revision history of the repository in the form of a tree graph, and you can see the new My branch I created. If you're looking to do more with your design through Active-HDL, you can use the Git commands within the console window, and you can also create your own batch or tickle script files, add them to the bin directory, and create your own TortoiseGit tool, just like I demonstrated. And that's the end of this video. As you saw, TortoiseGit seamlessly integrates with Active-HDL, creating a more robust design environment that can keep up with the ongoing design and verification of a team project. If you'd like more information on TortoiseGit and the available commands, check out the website's section on automating TortoiseGit, which I've linked below in the description. Thank you for watching.